Well, hello and welcome back. More Algorithm Man. Today we're talking about math in multiplication and looking at diagonal math and using these boxes once again. See issue 1 if you want to see how we started with it, but I want to walk through these again. Remember, the whole objective is to making it easier, so when we start talking algebra, when we start talking geometry, we've already set up a way that people see the math so it makes sense. So in this case, every single problem is going to be an area, so geometry is squares and triangles and things like that. So this one's going to be 56 times 37. And the way that we're going to solve this is we've set up this box, and each one of these smaller boxes is just this times this. So we're just looking at 3 times 5. At this box, it's 7 on this side and 5. So 3 times 5 is 15, and we're going to write it like this. Just like that. Then we're going to go to this box over here, and 7 times 5 is 35. Then down here, 3 for this side, 6 for this side, so that makes that an 18. And then 7 times 6 is 42. Now the reason I like this, and I know it can be confusing at times, you've got to remember that this column right here is our ones column, this is our 10 looking diagonally, this is our hundreds, and this is our thousands. And using that concept that instead of working right to left, unimportant to important, we're still going to work from the top down. So when I add these up, I'm still going to think with the numbers that my mind can hold best. So in the thousands column, I've got 1,000. In my hundreds column, I've got 900. So that's 1900. In my tens column, I've got 5 plus 4 is 9 plus 8 is 17. So that's 17 in my tens column plus a 2. And then when I add that all up, I have 2,072. Alright, let's do it over here. Once again, 1 times 4. Now if you don't have anything in the hundreds column, that's just going to be a 4. 9 times 4. 36. And stick with me because we're going to do the algebra too. 1 times 2 is 2, and 9 times 2 is 18. Once again, remember, this is your 1 to the 0 or your ones column. This is your tens column. This is your hundreds column. And this is your thousands column. This is also 10 to the first, 10 to the second. Anytime we can start adding new things to people's understanding, it gets even better. And I want you to see these firsts, seconds, and thirds where we start talking algebra. So 0 in the thousands, 7 in the hundreds, 9 in the tens, and 8. Well, that's just going to be 798, and I can start doing that in my head. Now, on this one, we can see 34 times 175. We're still going to set it up just like that. And once again, here's our zeros, here's our tens, this is our hundreds column, this is our thousands, and then this is just our 10,000s column. Okay? So 1 times 3, 3. 21. 15. Now you notice you still have to remember all these facts. There's no getting around that. You got to memorize your facts. So 0 in the 10,000s, I have 5,000, and I can either write that or I can start just adding that up in my head. 1, 2, 4, 4, that's 800. 5 and 2 is 7, that's a 15, so, and there's our answer, 5,950. Alright, now hold on one second because I want to show you how this works when we start talking about algebra. So I'm going to make those same boxes again. Give me a second here. Oh, it's strong. Okay, not as pretty. I promise I'll be prettier next time. But what if we started having something like this? X plus 2 times x minus 7. A lot of people start teaching FOIL and distributive properties and lots of other things, but if you already understand this box, you can put an x and a plus 2 and an x and a minus 7. Now one thing that's going to be a little bit different, and we'll talk about it next time, is if I've got a minus and a plus. In fact, let's make this a negative so you can see that that's a negative. What's going to happen is any time where the boxes have different, those are going to be differences. So I'm going to start by putting a negative there and a negative there. Anywhere where the boxes have the same sign, same means some means plus. So different sign, difference, different sign, difference, same sign, same sign. That means if these were negatives, and we'll do one like that, that it would still be positive. So let's remember how I showed you those tens to the 0 to the first to the second? This box is now going to be our x squared box. These are going to be our x to the 1 boxes, and this is going to be our x to the 0 boxes. And anything to the 0 power is 1, so it's going to go away. So when we solve this, Same thing, x times x, that's just 1x squared. 7 times x is minus 7x. 2 times x is 2x. And 7 times 2, negative 14. And the nice thing is, if we've been doing this for a long time, we're already thinking on these diagonals. So we've got our x to the zeros, our x to the ones, and our x squareds. Answer, x squared minus 5x minus 14. Because all we did was put the 7 and the 2 x's together. Okay, let's do one where I talked about, here we go. Not as pretty of a box, didn't have it pre-planned. My apologies. We're going to do, oh, here, let's write it over here. We're going to do 2x minus 3 and x minus 4. Okay, 2x, I'm going to write my 3, my x, and my 4. And then, just so we can see it, I'm going to make that a negative and that a negative. So now when we cross-reference the boxes, these two boxes are both plus. This box is now going to be a minus because that's a plus and that's a minus. This box, minus and a plus, different. Minus and a minus, same. Same means some, that means that's positive. And now I just do my multiplying. Keeping in mind, this is going to be my x squared boxes. These are my x to the 1 boxes. And these are my x to the 0. And anything to the 0 power is just a number. So, I've got 2x squareds. I've got minus 8. I've got x and minus 3 is minus 3. And then I have 4 times 3, which is 12. So my answer, working on the diagonals, 2x squared minus 11x plus 12. Alright, thanks for dropping by. Come see me at anyonecandomath.com. I'd love to help with whatever your questions are. Bye-bye.